And we're going to go over this problem. To solve this problem, x plus 7 squared equals -4. The perfect setup, it is a perfect setup for doing what we call the square root method. It's the quickest method that's going to give us the correct answer. We take this, whenever we have something squared equaling a number, we take the square root of the side that's squared, which just removes the square. It just gives us the x plus 7. And on the other side that's not in the square, we do the square root of it by doing plus or minus the square root of the number, which is -4. Now, if you remember, the square root of -4 is actually the square root of 4 times the square root of -1, which is 2i. So that we get that x plus 7 equals plus or minus 2i. And since I want to find out, I want to solve for x, I have to bring the 7 to the other side. So I'm going to subtract 7 from both sides. And that'll give me x equal. Remember, I told you when you're doing this, you always want to bring the number that you bring over, you always want to put it first. So that'll be the -7. And that'll be plus or minus 2i. And that is choice number A. I hope a bunch of you got that correct answer. Any question about this? You could have also, and I've seen this done on a multiple choice test, instead of writing the answer this way, they write the answer as two separate answers, -7 plus 2i and -7 minus 2i. So you can write it separately. That's what the point of this plus or minus is. Again, it gives you two answers. We can't combine these because they are not like terms. These are what we call complex numbers. Okay, so going back to what the last thing we were talking about, we talked about solving quadratic equations using the quadratic formula. And that's where I'm going to really start again. And then after that, I will review the completing the square method by doing an example like that as well. But let's first start with the formula. First of all, let me just write down the information that we had talked about on Thursday in terms of the formula. We said that every quadratic equation could be written in the form of ax squared plus bx plus c equals 0. In other words, when I see I have an x squared in my equation, I know I have a quadratic equation. And what I'm going to do is look at the three numbers, the number in front of the x squared, the number in front of the x, and the number that doesn't have any x connected to it. That's what we call the A, the B, and the C. And I know these three numbers are what I need to fill in order to use the formula, which looks like this. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. This formula is probably the most important formula that we're going to be dealing with this term because it allows us to solve any quadratic equation. Whether we can factor the quadratic equation or we can't, whether we can use completing the square or we can't. We always can solve a quadratic equation if we have this formula. So you must memorize this formula. If you go on to another course, and I hope a lot of you will go on to pre-calculus, you're going to use this formula a lot. It happens to be extremely important. Let's say I gave you this equation, this form, and asked you to solve it. X squared minus 13x plus 36 equals 0. It happens that this could have been solved using factoring. Let's just see that this could have been solved using factoring. After that, I'm going to go back and solve it using the quadratic formula, because I'm going to show you it doesn't matter if you can factor or not. If you want to use it, you can, for every quadratic equation, you can use this formula. But first, let's solve this by the first method we ever learned, which is factoring. Remember what we did? We first set it equal to 0, which it is, and then we break it up into 2 parentheses. The x squared, of course, we break up into x and x. The last term is positive. That means both signs have to be the same. And since the middle one is negative, it means they're both negative. And we need 2 numbers that are going to multiply to 36. And when we add them, are going to give me 13, which is obviously 4 and 9. So my 2 parentheses become x minus 4 and x minus 9. And then, if you recall what we did, we set each of them separately equal to 0. So we got x minus 4 equal to 0, and also x minus 9 equal to 0. And solve each of these little equations. So this gives me x equals 4, and this equation gives me x equal to 9. So that the solution to this quadratic equation turns out to be the numbers 4 and 9. That is the way we always solve these quadratic equations in this course until we got to this chapter. We had to be able to take, mostly it's a trinomial, we had to be able to take it and factor it. Let's see how we could have solved this equation using the quadratic formula. So I'm going to erase this and start all over. Obviously, I'm going to show you that the answers you're going to get are exactly the same answers that you have over here. Now, if we want to use the formula, the first thing we have to do is decide what is our A, what is our B, and what is our C. Now, the A is always a number in front of the x squared. Since there's nothing there, it's understood to be a 1. The B is a number in front of the x, which in this case is a negative 13. Don't forget the negative is part of the number. And the C is the standalone, the number that doesn't have any x next to it, which is positive 36. And what I have to do is take those 3 values and substitute them into the formula. Here's the formula. Wherever I have a letter, I'm going to put a parentheses in front of it. Instead of it, sorry, like if we have negative B, I'm going to put negative with a parentheses and fill in the parentheses with a number that's equal to B. So that number is negative 13 in this case. Then I have a plus or minus the square root. And again, I have a B squared. So here's my parentheses squared that I'm filling in with negative 13 minus 4. And now I have 2 parentheses, one for the A and one for the C. The A I know is 1. The C is 36. And all of this goes over to A. So here's 2 in my parentheses for A, which is just a 1. So I take the specific numbers from the equation and stick it into the formula, and the rest is just simplification. First of all, I see I have a negative and a negative. A negative and negative becomes a positive 13. Now, the hardest part, or the part that I have to be most careful with, is what's inside this radical. So the first thing I see is negative 13 squared. That means I'm multiplying negative 13 times negative 13, which is going to give me a positive of 169. be very careful if you're doing it on your calculator that you put the negative 13 inside a parentheses before you press squared. Because if you write negative 13 and then you square it, it'll give you negative 169. It doesn't know that you want to square the negative as well. So be very careful with that sign. That first number is b squared. It's always got to be positive. Then I have a negative 4 times a 1 times a 36, which if I do that on my calculator, which I want to do, gives me 144. So I get 169 minus 144. And when I subtract it, I get 25. And all that goes over 2 times 1, which is 2. Now, what happens to be, the number inside the radical at this point happens to be a perfect square. In other words, the square root of 25 is a rational number. Sometimes we get a number like 17, so my answer is going to be irrational. And sometimes I get a number like negative 25, which means the square root of negative 25 will be 5i. So sometimes my answers come out to be regular rational numbers, just plain numbers. Sometimes the answers come out with radicals in them. Sometimes they come out with i's in them. It doesn't matter. Our formula is able to take care of all of those. Okay, in this case, I see the square root of 25 is just 5. So that my answer is coming out to be 2 answers. 13 plus 5 divided by 2 for one answer, and 13 minus 5 divided by 2 is your other answer. Remember, this plus or minus can be separated into 2 different answers. In this case, these are like terms and they can be added. 13 plus 5 gives me 18, and I divide by 2, which gives me 9. And 13 minus 5 gives me 8. And when I divide it by 2, it gives me 4. And again, my answers are 9 and 4, which is exactly what I got. Obviously, this was more work, but again, it proves that you can use this method to solve a quadratic equation. Okay, what I'm going to do is I'm now going to take another example and do it using the completing the square method, because those are the 3 methods that we've used to solve quadratic equations. This particular example would not have been a good example to do the completing the square method. If you recall what I said, when you want to use this completing the square method, you want your leading coefficient to be 1. In other words, the x squared should stand alone without anything in front of it, which it does, so that's okay. And the coefficient of the x, the number in front of the x, should be an even number. This is not, this is a 13, because in the completing the square method, we have to divide this number by 2. And if it's not an even number, when we divide by 2, we'll either get fractions or decimals, and it makes the whole process much more difficult to deal with. So I personally only use the completing the square method when my A is 1 and B, the A and B that I'm talking about over there, is an even number. So let's take an example like that, and I'm going to do it using the completing the square method. Then what I'm going to do is I'm going to go back and let you try that same problem using the quadratic formula to see that you actually can get the same answer with whatever method you use. Okay, so I'm taking a different problem. Okay, I'm erasing these numbers because those were the numbers from before. And I'm taking a problem. Let's say I wanted you to do this problem. x squared plus 6x plus 3 equals 0. Notice this is a good setup for the completing of the square because the x squared leading coefficient is 1 and the number in front of the x is even. So that's a good setup. And you might notice that you couldn't even use factoring in this case because there are no numbers that multiply to 3, but when you add them are going to give you 6. It's not something that you would have been able to solve by factoring. So let's go through the steps of solving this using the completing the square. Unlike the factoring method and the formula method, when we doing it by completing the square, we want to make sure to bring the number alone to the other side, that we only have x terms on the left side. So I'm going to bring this 3 to the negatives to the other side. So that'll give me x squared plus 6x equals a negative 3. Now, if you notice, I left a space here because in completing the square, I have to put in a number. I have to make these two terms, I have to add a third term to it, so I get a trinomial that can be written as a binomial square. I need this to be a perfect square. And the pattern that we do is we take the number in front of the x and divide it by 2. That's why we want it to be even. So that gives me plus 3. And what I do with that number is I multiply it by itself. 3 times 3 gives me 9. I have to add 9 to make this a trinomial that's a perfect square. But whatever I add on one side, I add the exact same thing on the other side so that my equations maintain their balance. And therefore, I can then write this as x plus 3 squared. That's what this is. I forced this into be a perfect square trinomial and factored its x plus 3 squared. And you'll always be able to tell what this number should be because it's always half of this number. It's also the square root of this number. But if you look at this number, at least you'll get also not only the number, it's very easy to figure it out, also you get the right sign. It has to be positive in this case because this was a plus 6. On the other side, I have negative 3 plus 9, which gives me positive 6. And now we're back to where that very first problem that we talked about, where we use the square root method. We take the square root of the x plus 3 squared, which just gives me the x plus 3. And I do plus or minus the square root of 6. And then to get what x is, I bring the 3 to the other side. So I get x equals negative 3 plus or minus square root of 6. And that's my answer. Notice the square root of 6 is a radical, that it's not, 6 is not a perfect square, so I can't take its square root. So my answer is what we call irrational. And I can leave my answer like this because these are not like terms. You can't add a negative 3 with a square root of 6. They are not like radicals. If you want your answer in radical form, this is your answer. If you want to write it separately, you could write it separately. You could write it as negative 3 plus radical 6 as one answer, and negative 3 minus radical 6 as your other answer. Sometimes it's written with a plus or minus. Sometimes it's written as two separate answers. They mean exactly the same. Just to go a step further, sometimes when you get a radical answer, not when you get an I, but when you get a regular radical answer, they want you to figure out the answer as a decimal. They want you to round off your answer. Suppose they say, round your answer to tenths position. How would we go about doing that? What do they mean when they say round your answer to the nearest tenth? So what you have to do, and you must have a calculator to do this, is you've got to figure out what the square root of 6 is in decimals. So I open up my calculator and I do the square root. I hope you know where the square root button is on your calculator, and I do the square root of 6. Now, when I go to the square root of 6, what I got is something that looks like this: 2.44949. There are even more numbers after that, but I don't need them. It goes on and on for 10 digits. It doesn't go any further because there's no space on the calculator, but it could go even further. It could go up to 100, 1,000. It's a non-ending, non-repeating decimal. Now, for my purposes, I would just go to 3 decimal places. In other words, I'd use 2.449. You don't have to use all 10 digits. So if I want to find out what these answers are in decimals, for one answer, I'm going to have to do -3 plus 2.449. And for my other answer, I'm going to have to do -3 minus 2.449. So all I have to do is go on my calculator and figure out the number to go to just 3 decimal places. That's usually enough. And use that number, and then use your calculator to figure out the rest. Okay, so one number I'm doing -3 plus 2.449, which gives me -0.551. And I said I wanted it to the nearest tenth. The nearest tenth is the first decimal place. So I look at the second decimal place, which is a 5. That means I have to go up higher. When your next digit is 5 or more, you have to round up. So this becomes, in rounded off fashion, -0.6. The other answer I do by doing -3 minus 2.449. And that gives me -5.449. And again, I want to round off after the first decimal. So I look at the next number, which happens to be a 4. It's less than 5. So I drop it. So again, it becomes -5.4. So in decimal form, if you're asked to nearest tenth, here would be your answers in decimal form. Usually the answer, they want you just leave it in radical form. Simplest radical form. In other words, simplify your radical. But if you say, what is the answer to the nearest tenth or the nearest hundredth, they want you to take your calculator and figure out what that radical is, and then use it to figure out your answer. So now, what we're going to do is I'm going to ask you to do this problem again, just to in radical form, using, instead of completing the square method, to use the formula method. See if you could solve that using the formula. See, practice. I want you to practice this. So I'm going to give you a few minutes to do that while I take attendance. Does anybody, can I erase what's on the board right now? Anybody have a problem with that? Okay. So I'm going to start with the equation. Here's the equation. Again, I want the answer. You don't have to go to the nearest tenth anymore because that's the same. That would be the same process no matter what. I want you to use a quadratic formula to solve this equation. I'm going to, while you're doing that, I'm going to take attendance. So let's work on this problem. If we want to use the quadratic formula, the first thing we have to do is decide, and I always write it down actually when I use the quadratic formula, what is the A, what is the B, what is the C? For that particular equation, the A is obviously 1 because there's nothing in front of the x squared. It means it's understood to be 1. The B is 6 and the C is 3, and they're all positive numbers, so therefore I don't have any negatives anyplace there. So now what I'm going to do to solve this equation is I'm going to put in place of, in my quadratic formulas, all those numbers. So here's my quadratic formula. X equals negative b. So remember, I put a parentheses, and in place of that, inside that parentheses, I put the b, which is 6, plus or minus. Remember, for each of the letters, I put a parentheses. The first, that in this one, it's b squared. So the b again is 6 minus 4, and now there's going to be two parentheses, one for A and one for C. The A is 1, the C is 3. I'm sorry, it's not 6, it's 3. It's just a matter, you have to be careful. I have to be careful also. Over 2 times A, again, here's my parentheses for the A, and the number for A is 1. And now it's a matter of simplifying. So this just becomes a negative 6 plus or minus. Okay, here we have to be careful. 6 squared is 36. And this is negative 4 times 1, which is negative 4. And negative 4 times 3 is minus 12. So what's in here is 36 minus 12, which comes out to be 24. So this is the square root of 24 over 2 times 1, which is 2. All right, I'm really finished now. It's just simplifying. First of all, the square root of 24 can be broken down into 4 and 6, which is 2 radical 6. So this becomes negative 6 plus or minus 2 radical 6 divided by 2. Now, if you notice, the numerator is a binomial. It's a negative 6 and either a plus or a minus 2 radical 6. The denominator is a single term. It's just a 2. If I want to reduce it, I have to find a number that goes into all 3 of them, into the negative 6, into the 2 radical 6, and into the 2. Now, when I'm looking at this 2 radical 6, I'm only looking for a number that's going into the 2 part, the number in front, because you can't divide a number inside a radical with a number outside. So it has to be outside with outside. Also, I have to divide it into all 3 of them. If it only goes into 2 of them and not into 3, I have to leave it. This is a binomial divided by a monomial. You're dividing into each term. So I see each of these is divisible by 2. So 2 divided by 2 gives me 1. Negative 6 divided by 2 gives me negative 3. And 2 radical 6 divided by 2 gives me 1 radical 6. In other words, my answer comes out to be negative 3 plus or minus, well, 1 radical 6 is just radical 6, divided by 1. And now remember, when you have a 1 in the denominator, you don't have to put it in. And this is exactly the same answer that we got from the completing the square method. Again, I'm not going to ask you to do it in decimal form because it's the same numbers. But notice you had to simplify by dividing each of the terms by 2. Is there any question about this? Would you like to try one more? Should I give you one more to try? Let's do one more like this. give you, let's do another example. I'll give you again time to do it, and then we'll do it together. Okay, here's the problem. It says use a quadratic formula, but I'm not even specifying which method to use. I just want you to solve it. Solve this quadratic equation. X squared minus 4x plus 29 equals 0. And I'm going to give you, it's a multiple choice question, so I'll give you the possible answers. 7 and negative 3. 4 plus or minus 10i. Negative 2 plus or minus 5i. Or 2 plus or minus 5i. Okay, I'm going to erase these numbers. And you can either do it any way that you feel will work for you. I'll give you about 4 minutes to work it out. Okay, I think it was enough time. Let's work on this together. I am going to solve this using the quadratic formula just because I want you to have practice in the quadratic formula. But if you notice, this actually could have used completing the square method as well, because the leading coefficient is 1 and the number in front of the x, the b, happens to be an even number. So it'll work equally well using the completing the square. But again, I'm going to use the quadratic formula. The a in my quadratic formula is going to be 1. The b is going to be negative 4. And the c is going to be positive 29. And I'm going to stick that into that formula. So it's going to be negative, here's my b, negative 4, plus or minus, here's my square root, here's my b squared, that's the negative 4, minus 4, here's my a and my c. My a is 1, my c is 29, and that's all over 2a, so that's 2 times 1. Okay, so all I did was take those particular numbers and stick them into the formula. Now, I'm going to simplify. Negative and negative become positive, so this becomes 4 plus or minus. Okay, now negative 4 squared is negative 4 times negative 4 is positive 16. Be very careful with that. And negative 4 times 1 times 29, so that's 116, I think. You could certainly do that on your calculator. And 16 minus 116 is negative 100. Notice there's a negative number inside the radical, which means my final answer has to have an I. I know right away this answer can't be right. Now let's go further. 2 times 1 is 2. Now, the square root of negative 100 is the square root of 100 times negative 1. So that's 10i. So this becomes 4 plus or minus 10i divided by 2. And here, this is my binomial, and this is my monomial. My binomial on top, my monomial on the bottom. All 3 of these numbers are divisible by 2. So 4 divided, the 2 divided by 2 is 1. The 4 divided by 2 is 2. The 10 divided by 2 is 5. So that my final answer becomes 2 plus or minus 5i, which was choice D. I hope most of you did get that answer. Again, you could have done it using the completing the square method. You would have gotten the exact same answer. All right, so we're going to continue from here. Now, this is the end of chapter 7. We learned how to solve any quadratic equation. That's what chapter 7 was all about. We're now going on to chapter 9. We're skipping chapter 8 right now. We're going on to chapter 9. After we finish chapter 9, we will then do chapter 8 and one other chapter that will be left to be done, which is going to be a chapter that is not covered in the book. It's called trigonometry. We will do that as well. And that really means, and that's the end of the term. In other words, we have 3 more chapters, the chapter we're starting now. Once we finish chapter 9, the chapter we're going to be doing now, then there'll be another test. I'm not sure if that test will be on Delta Math or on Blackboard, but in addition to that, there's going to be one final test that's going to be a review test of everything. And that'll definitely be on Blackboard because you have to practice. Okay, no problem. Have a good day. I'll see you on Thursday, Odalis. Okay, so we're going to be starting now. Let me erase this. I'm going to start chapter 9. And that's where we're going to be continuing on Thursday. Again, anybody that has any questions about anything, please email me, or you can stay after class. If you want to stay after class and I'll talk to you after class, that's fine also. Just send me a chat that you wanted to talk to me after class and I'll stay on after everybody leaves. Okay. The next, chapter 9, is called conic sections. I'm going to first describe what a conic section is, and then I'll tell you why that name is used. None of that is so important except that you have to know what do the conic sections refer to. The conic sections are pictures, graphs. Remember, we're doing graphing, so we're going back to graphing of quadratic equations. The beginning of this term, one of our first topics that we talked about was graphing of linear equations. A linear equation is another way of saying a first degree equation, an equation that doesn't have any exponents. And the reason it's called a linear equation comes from the word line, because when you graph it, when you make the picture of the graph, the picture you get is a straight line. It turns out when you make the graphs of quadratic equations, you don't get straight lines. You get one of 4 different shapes. The 4 different shapes you can get are the circle, the ellipse, the parabola, and the hyperbola. These 4 shapes are referred to as the conic sections. Just like the lines, the equations are called, lines are called linear equations, the quadratic equations are called the conic sections. Let's look at what these shapes look like, and then I'll tell you why they're called conic sections. You don't have to know why they're called conic sections. You just have to know that that's what they're called. If I use the word, if I gave you a question like this, which of these is not a conic section? And I gave you a choice of circle, hyperbola, rectangle, and parabola, you'd have to tell me rectangle, because the conic sections are these four, and rectangle is not one of them. So you have to know the four words that make up the conic sections. What does a circle look like? Well, you know what a circle looks like. Something like this. Here's a circle. Maybe this is the center. Well, it's the same distance from the center, no matter what point you take it. If you have a, this is a two-dimensional figure. If you had a three-dimensional figure, then of course it would be something called a sphere. But this is a circle. The important thing about a circle is to know where is its center and how long is its radius. An ellipse is similar to circle, except it's flattened out. It's it's an oval more, an oval shape. It's as if you took your, let's say you had a totally round balloon and then you squeezed it, then you wouldn't get a perfect circle anymore. You'd get something that's more oval shaped, something like this. That would be an ellipse. And sometimes it's squeezed from top to bottom, and sometimes it's squeezed from left to right. So sometimes you get an oval that's longer horizontally, and sometimes you get one that's taller, like vertically. That's something called an ellipse. You see an ellipse, actually the shape of the earth is not a perfect sphere. It happens to be flattened down at the poles, so therefore it is more an ellipse. A parabola is a shape that looks like a U. It's not exactly a U because even its sides keep going up and up and up and out, but they keep going out as well. But basically, the important thing is it's a U shaped where it has a bottom, or sometimes it's an upside down U. This is what's called a hyperbola. This is a parabola. A U shape, a single U shape. Again, be careful that the sides don't go straight down. They keep going out further and further. The hyperbola is the strangest of them all. It consists of two branches. It could be something like this, two branches that sort of vertical branches that face away from each other, or it could be, as you call it, horizontal, where the two here the branches are crossing the x-axis, here they're crossing the y-axis. But basically it's two branches that face away from each other. These four shapes are what we call the conic sections. And the reason we're studying them is because they're the shapes that we get when we go to graph quadratic equations. So graphing quadratic equations is quite a bit more involved than just graphing a linear equation, because you have to know ahead of time what kind of shape you're going to get. And that's one of the things we're going to look at. Can I look at a quadratic equation, something that has x's and y's and x squareds and y squareds, and can I know ahead of time by looking at the equation what shape it's going to be? Before we start discussing these individually, I just want to give you an idea as why the term conic sections is used. Even though you don't have to know this, you just have to know which are the conic sections. Here's the reasoning behind it. Let me just erase this so you can get a picture of what can happen. The word that you might see in conic sections, just like in the linear equations, you see the word line. In conic sections, the word you see is cone. Let's say you have an ice cream cone like this. Here's your ice cream cone. It doesn't have any ice cream in it, so we don't have to worry about it spilling. Maybe we have one facing up, and it's right on top of one that's facing down. Okay, now you have to use your imagination because these are three-dimensional figures. Let's say you're looking at an ice cream cone or straight down at it, and somebody made a cut straight across, right? Wouldn't you see the shape? Remember, the ice cream cone is empty, so all you're seeing is the edge. If you cut off the top, the shape you would see would be a circle. That's if you went straight across. But what if you weren't so careful? And instead of going straight across, you sort of went down at an angle like this. Okay, think about it. Wouldn't it then elongate your circle and you get a shape like an ellipse? Whereas, if I would cut through it so it went through the top, think about it. It's going from here, then it's coming around, and it's coming back up to here. Doesn't that the shape look like the shape you would get from an parabola? Whereas if you cut straight up and down between the two between the two cones, here you get a U going up, here you get a U going down, and you get something like the hyperbola. So therefore, these are called conic sections. A section is where you're cutting. If you cut your cone in different directions, you get one of these four shapes. Again, you don't have to remember that. You don't have to know that. You don't have to know how to cut it. You can look in the book if you really want to see better pictures, because they do have better pictures. But the important thing is to remember the conic sections are the graphs you get from quadratic equations, from different types of quadratic equations, and it could be any one of these four: the circle, the ellipse, the parabola, or the hyperbola. Okay, we're going to start by discussing the circle. And next time we'll go on, we'll do the ellipse, we'll talk about the parabola, we'll talk about the hyperbola. The hyperbola is the most complicated one, but we have to know very little about it. Whatever we do here, we're not going very thoroughly into each of these topics. So if you were going on to a higher mathematical course, what we're talking about, it would be built higher when you go into more, let's say, into pre-calculus or calculus course. So we're just getting a taste of this. Okay, the simplest type of circle that you might encounter in a graph would be a circle whose center is right at the origin, and whatever its radius is, let's say the radius is 3. What that would be telling us that if I wanted to draw it, I have to go 3 in all directions. 3 to the right, 3 to the left, 3 up, 3 down. And if I connected those points. Obviously, I'm not going to connect them with straight lines. I'm going to be curved. I get this circle. Okay. The equation of this circle is x squared plus y squared equals r squared. Any circle whose radius is at the center, whose center is at the origin, has an equation x squared plus y squared equals the radius squared. So for this particular example, the equation is x squared plus y squared equals 9, because my radius is 3, so it's equal to 9. If I would give you something like x squared plus y squared equals 25, you would know that that is a circle also, because it has an x squared plus a y squared. That's the important thing. Both the x and the y have exponents of 2, and their coefficients are 1. 1x squared, 1y squared. There's nothing else there except this equal 25. The square root of this number is the radius. So the radius in this case would be 5. Notice this, that means that this number on the other side always has to be a positive number. Now, what would happen if we had a circle and the center was not at the origin? What if I have a circle that looks like this? So let's pick a point. Let's say I say the center of my circle is 2, -3. And let's say the radius of the circle is 4. First of all, let's draw it, and then we're going to talk about what the equation of that circle is going to be. So in order to draw it, I first go to the point 2, -3. So I go 2 to the right, 3 down. Now I'm going to draw this one green. These are the graph lines. The graph paper has lines on it. There are lines going up and down and across. I just did the ones that went straight through the point. To draw this, I'd have to go to this point and go 4 in each direction. 4 up, 4 down, 4 left, 4 right. So let's do that. 4 up. 1, 2, 3, 4. Here's one point. 4 down. 1, 2, 3, 4. 4 to the right. 1, 2, 3, 4. 4 to the left. 1, 2, 3, 4. So now this one's a little bit. And then I just connect my points. Again, the center, you have to know what the center is, but it's not part of the circle. The circle is the, so that's what this circle would look like when its center is not at the origin. It turns out that the equation of the circle that's not centered at the origin has an equation that looks like this. X minus a squared plus y minus b squared equals r squared. Again, you're going to have an x squared, see the x is squared, and a y squared, but the x and the y are going to be in parentheses, and inside the parentheses are going to be numbers that have to do with the center. The center of the circle is the A, B. So if A is the X of the center, we do X minus A. If B is the Y of the center, then we do Y minus B, and we do squared. Let's say my center is 2, 3. That means that my A is 2, and my B is -3. So for this particular circle, my equation would be X minus 2 squared plus Y. Now look at it, it's negative a -3. There are two negatives here. It's Y minus B, and B itself is negative. And a negative and a negative always becomes a positive. So it becomes Y plus 3 squared equals R squared. Now the R we know is 4, so it's equal to 4 squared. In other words, this becomes X minus 2 squared plus Y plus 3 squared equals 16. And notice the numbers that are inside the parentheses are just opposite in sign to the actual numbers that are the center. We do X minus 2 and Y plus 3. You an equation that looks like this. Suppose I gave you X plus 1 squared plus Y minus 4 squared equals 36. Then you would be able to tell, because you have this plain X squared and a plain Y squared. Notice there are no numbers in front of the X or the Y, but they're being squared because they're inside the parentheses with a 2 on the outside. That would make this a circle where the center of the circle, these are the important things you have to know about a circle. Its center and its radius. The center of the circle would be -1, +4, because you have to change these signs. And since this is 36, your radius would be the square root of 36, which would be 6. And notice once you know your center and your radius, then you can draw your circle. Okay, here, I want you to try one on your own. I'm giving you this equation. Let me do something else. I'm giving you the center. I'm giving you that the center of my circle is the point 4, 0. And I'm telling you that the radius of the circle is 8. See if you can write the equation of the circle and see if you could draw a picture of the circle. I'm giving you a few minutes to try this. Okay, let's see if we can figure this out. First of all, let's draw this. We know the center is going to be 4, 0. That means 4 to the right and right on the x-axis, because the y is 0. That means we're not going up or down. Now the radius is 8, means I have to go 8 in each direction from this point. So 8 to the right would be 1, 2, 3, 4, 5, 7, 8. 8 to the left would be 1, 2, 3, 4, 5, 6, 7, 8. 8 down, I don't know if I have enough room. 1, 2, 3, 4, 5, 6, 7, 8. And 8 up. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to use my red marker for this. Obviously, this is not going to be such a good picture because I'm trying to do this freehand, but this is what approximately what my circle would look like. So what is the equation of this circle? So remember, the standard equation of a circle is x minus a squared plus y minus b squared equals r squared. The a in this case is 4. The b in this case is 0. And the r is 8. So therefore, my equation will become x minus 4 squared plus y minus 0 squared equals 8 squared, which is 64. And I can simplify this. I leave my x minus 4 squared. But y minus 0 is just y, so I can just write that as y squared equals 64. In other words, there's no parentheses around the y because it's not necessary because the number being added is 0. And this would be your equation of that circle. Again, there's an x squared. Sometimes the x is in a parentheses, but it's an x that's squared and a y that's squared. We're going to see that's going to be the thing that tells us that we have a circle. When we have both an x squared and a y squared, and the numbers in front of those numbers is just 1. The coefficients are 1. Okay, we're going to go a little bit further next time with the circle, and we're going to talk about the ellipse as well. Does anybody have any questions? They have anything they want to ask me? Again, don't forget that this afternoon I'm going to go down there and I'm going to put it on. There's going to be a test on Delta Math. You have until next Tuesday to complete it for complete credit. After that, there'll be a penalty if you don't complete it on time. It's not a major penalty, but there is a penalty. Also, if there's anything in the next couple of weeks, I'm going to be sending out emails to people that I notice are missing things. But you on your own should be able to tell if you're missing anything. It's going to affect your mark. If you're missing homeworks, if you're missing tests, all that's going to affect your mark. If you're missing tests, you're going to get a 0 for that test. So make sure you complete all your work. Again, this test is the 3rd test that's going to be on Delta Math. It's actually the 5th test we're having this term. We will continue with Chapter 9. Make sure to look on Delta Math also for any homeworks. There's definitely homeworks on the quadratic equations. Okay, everybody have a nice day. I will see you on Thursday again.